Hi, I'm Elke Ivanova. In this video, we'll show how to factor polynomials using the factor theorem. When the function f of x is divided by x minus k, it could be represented as the product of x minus k and the quotient polynomial plus a remainder. This is a well-known fact. For example, if you divide 9 by 2, you get a quotient 4 and a remainder 1 over the divisor 2. So we can express 9 as a product of the divisor 2 and the quotient 4 plus the remainder. It is the same for math. We know from the remainder theorem that if f of x is divided by x minus k, then f of k equals r, so we can replace here r with f of k and with f of x as a product of x minus k, the quotient polynomial, plus the remainder f of k. If f of k is 0, then the remainder is 0 and f of x will be just the product of x minus k and the quotient polynomial. We can say that x minus k is a factor of f of x. We just proved the factor theorem. X minus k is a factor of the polynomial f of x if f of k equals 0. Let's see an example. Is x minus 1 a factor of the following polynomial? Let's say f of x is a function that is defined by exactly the same polynomial. We will apply the factor theorem. X minus k, in this case x minus 1, will be a factor of our function f of x if f of k equals 0. So we can check that by using synthetic division. The divisor is x minus 1, so k will be 1. We'll bring down the coefficients of the polynomial, making sure that there is no missing term. 2 is the coefficient of the second degree term, negative 5 of the first, and 3 of the 0 degree term. Then let's apply the algorithm. We start with bringing down the leading term coefficient, 2. Then we multiply k by 2, we get 2. We add the numbers in this column, negative 2 plus 5 is negative 3. Then we multiply k by this number, negative 3, we get negative 3. We add the numbers in this next column, in this case the last one, we get 0. So this is the remainder. 0 is the remainder of dividing the polynomial function by x minus 1, and this remainder is 0. So according to the factor theorem, x minus 1 is a factor of the following polynomial. And because the quotient of this division is 2x minus 3, we can represent the given polynomial as a product of the divisor x minus 1 and the quotient 2x minus 3. The factor theorem could be used for factoring polynomials into linear factors. Let's see the following example. Factor f of x into linear factors given then k is 0 of f of x. F of x is the following function, k is 1. We can see if x minus 1 is a factor of f of x by using synthetic division with k equals 1. Let's do it. Bring down the coefficients of the given polynomial, 3 of the third degree power, then 5 second degree power, negative 24 the coefficient of the first degree power, and finally the 0 degree power has coefficient of 16. There are no missing terms here. Let's apply the algorithm. We start with the leading term coefficient 3. Then 1 times 3 is 3. 5 and 3, 8. 1 times 8 is 8. Negative 24 plus 8 is negative 16. 1 times negative 16 is negative 16. 16 minus 16 is exactly 0. So the remainder of this division is 0. It means that x minus 1 is a factor of the given function. And also f of x is the product of x minus 1 and 3x squared plus 8x minus 16. The goal is to factor f of x into linear factors We have one of the factors, and this is a quadratic trinomial, so we can factor it by using the AC method. The goal of this method is to find a couple of numbers, let's say m and n, such that the product is equal to a times c, in this case 3 times negative 16 or negative 48, and the sum is b, in this case 8. It is easy to see that one of the numbers will be positive, the other negative, and the two numbers are 12 and negative 4. These two numbers are used to split the middle term into two linear terms. So instead to get 8x, we get 12x minus 4x, and then we factor this polynomial by grouping. The first two and the last two terms could be combined. From the first two, we factor out the GCF, it is 3x. The other factor will be x plus 4. And from the last two, negative 4, the other factor is x plus 4. We have again a common factor, x plus 4. We factor it out, and we get x plus 4 times 3x minus 4. And now we can replace this trinomial with its factors. We'll get the linear factors of f of x.